This is section 2.7, part 3. In parts 1 and 2, we saw the ability to determine if an argument was valid or not by using truth tables. Now we're going to look at a way to figure out if the truth table is either valid or invalid using common arguments. So the first one we're looking at, and I'm looking at this yellow box here, is direct reasoning. So if I have premises 1, if P then Q, and premises 2 is P, the conclusion is therefore Q. This is called direct reasoning. This would be a valid argument. All right, so let's look at the next one. Contrapositive reasoning. Premises 1 is if P then Q. Premises 2 is negation Q. And the conclusion is negation P. So this is called contrapositive reasoning, and this is also a valid argument. In disjunctive syllogism, we have two options. P1 in the first option is P or Q, which is called a disjunction, or disjunctive, sorry. And P2 is negation P, therefore Q is the conclusion. Or I can have P or Q as premises 1. Premises 2 is negation Q, and the conclusion is P. Both of these are valid arguments. So let's look at transitive reasoning. P1 is if P then Q. P2 is if Q then R. Therefore, in conclusion, if P then R. This is called transitive reasoning, and it is also valid. The last two are examples of invalid arguments. Fallacy of the converse. If we look at the word fallacy, that means false. So P1 is if P then Q. P2 is Q, therefore P. That is an invalid argument. Okay? And finally, fallacy of the inverse is if P then Q for premises 1 or P1. Premises 2 is negation P, and the conclusion is negation Q. This is also an example of invalid argument. Okay, so what are we going to do with these? So what we're going to do is we're going to look through examples, and we're going to match up which one works. And when we match it up, we can tell right away if it's valid or invalid. For instance, let's look at this example. So when I look at this example, I have write the argument symbolically, then use a common argument to determine whether the argument is valid, state your reasoning. If I ignore my problems, then they go away. I ignore my problems, therefore my problems go away. Well, I have two things going on here. I'm going to let P equal I ignore my problems. And I'm going to let Q equal my problems go away. Okay, so if I look at sentence 1, remember sentence 1 is P1. So the first sentence says, if I ignore my problems, then they go away. So this is if P, then Q. In sentence 2, that's going to be P2, or premises 2. It says, I ignore my problems. That is P. And finally, my last sentence says, therefore, so I know that's my conclusion. My problems go away. That is Q. So when I match that up to one of the arguments in the table, I see if P then Q, P, therefore Q, matches direct reasoning. So it's direct reasoning, therefore the argument is valid. Okay, again, direct, contrapositive, disjunctive syllogism, and transitive reasoning are all valid. The only two that are invalid are the fallacy of the inverse and fallacy of the converse. Okay, so let's look at another example. If you study sets, you will better understand logic. If you better understand logic, then you'll better understand probability. Therefore, if you study sets, you will better understand probability. Okay, we have three things here. I'm going to say P equals you understand or sorry, you study, not understand. You study sets. Let's let Q equal you understand logic, or you better understand logic. And then I have an R as well. The R is you understand probability. Okay, so let's look at sentence number 1. If I study sets, you will better understand logic. Okay, so that's if P, then Q. So that's a conditional. And that's going to be premises 1. It's my first sentence. Second sentence, if you better understand logic, that's Q. You will better understand probability. Okay, so it's an if then as well. So if Q, then R. So this is P2. Then my last sentence says therefore, so I know I'm in for my conclusion. If you study sets, that's P. Then you'll better understand probability. I know it doesn't say the word then, but it's inferred there because we have that if you study sets. So you understand probability is R, so if P, then R. So I'm going to look up at the top here and pick one that matches. So if I look at it, I can see transitive reason says if P then Q, if Q then R, therefore if P then R. And that's exactly what I have. So this is transitive. I'm making sure I spelled that right. Transitive reasoning. Okay, so if it's transitive reasoning, then we can conclude the argument is valid. All right, let's look at the next one. Write the argument symbolically, then use a common argument to determine whether the argument is valid. State your reasoning. Paul will eat pizza for lunch, or Daria will order delivery. Dari did not receive delivery, therefore Paul ate pizza for lunch. All right, so let's let P equal Paul will eat pizza for lunch. And let's let Q equal Daria will order delivery. All right, so let's look at line number 1. So this is going to be premises 1. Paul will eat pizza for lunch, that's P, or Daria will order delivery, that's Q. So I have P or Q for line 1. Premises 2 is the second sentence. Daria did not order delivery. Okay, so that is negation of Q. Now, the last sentence, we have, therefore, Paul ate pizza for lunch. So that is P. So the only one that has an or as premises 1 is disjunctive syllogism, but let's make sure it matches up. Okay. So if I look up here, I have P or Q, therefore P or Q, premises 2 is negation P, therefore Q, or P or Q, negation Q, therefore P. And that matches, so it's disjunctive syllogism. Okay, and therefore the argument is valid. All right, I'm going to pick up right here on this next one, so I'm going to make a part 4 for 2.7 here. So thank you for watching part 3, and we'll look at part 4 together.